Hello everybody, good morning. My name is Nirbhay Kosare from Mechanical Department. Today the topic of our presentation is thermodynamics and its system. It's presenting by Atharva, Yash and me. And our guidance is Professor Raul Bamnisa. Let me introduce you to what is thermodynamics. Next slide. There are many definitions of thermodynamics, but in simple words, we can state as the science which deals with the relation between heat, work, and equilibrium. Next slide. We know that the study of science in the base of experimental results and observation of common experience of an individual which has led to discovery of various laws of thermodynamics mostly initial around four laws. First law, second law, third law, and zeroth law of thermodynamics. So first law of thermodynamics says that energy cannot be created or destroyed. It can be changed only from of energy to another form of energy. The work delivered to the system is directly proportional to the algebraic sum of heat taken off surrounding. Then second law of thermodynamics states that the energy in the form of heat only from a region higher from a region temperature to, to that of lower temperature. Then the second law of thermodynamics has two statements, Kelvin Planck statements and Gauss statement. In Kelvin Planck statement, it's impossible to construct an engine which gives 100% efficiency. Then Gauss statement that impossible to construct a device operates on a cycle and produce no other effect than the transfer of heat from cold body to hot body. The third law of thermodynamics states that the temperature of system approaches absolute zero, its entropy becomes constant or change in entropy is zero. Then zeroth law of thermodynamics states that if two systems are in thermal equilibrium separately with a third system, then they must be thermal equilibrium with each other. Now I would like to call Atharva. Explain next slide.
Good morning. Let us first know something about thermodynamic system. But before that, we should all know some basic concepts of thermodynamic system. It's basically divided into three parts: system, boundary, and surroundings. Next slide, please. So, as we can see in this diagram, the central part of the particular diagram is the system. Uh, the ring around it is the boundary, and every space or the region of space, excluding the system, is known as the surrounding. So, basic definition is system is what is the prescribed region of the space. Boundary is what actual, or you can also say an hypothetical envelope, which covers enclosing the system, and then surrounding is the region which excludes the envelope of the system. Next slide. There are many types of system, so we'll know about them in brief. First is closed system. So basically, if the boundary of the system is impervious to the flow of matter, which means that if matter cannot come in or go out of the particular system, then it is called as a closed system. The second type is open system. Herein, the matter flows in or out of the system. We also have diagrams in order to explain it more better. Next slide. So as you can see, these are the two diagrams for a closed system and open system. In the first diagram, as you can see, the mass is going to remain constant. The we have also marked the boundary, and there is no inlet or outlet for any matter to pass. On the second hand, in the diagram of open system, the mass will not remain constant because there is an inlet and outlet for the flow of matter. So that's the basic difference between closed and open system. Next slide, please. Uh, Other systems which we know are isolated system. Isolated system is a system which exchanges neither energy nor matter, which means that uh, not just matter but also energy is not exchanged when it comes to isolated system. Next is adiabatic system. Adiabatic system is which thermally insulated from its surrounding. Then next is homogeneous system. So the homogeneous system is which consists of single phase, uh, for example, say a moisture mixture of air and water vapor. And the next part is heterogeneous system. This is a system which consists of two or more phases. An example of it is water plus steam. So let me call
Hello everyone, myself Yash. I am here to speak about the thermodynamic approach we consider while studying the subject. There are two different approaches to undertake the study of thermodynamics. First is the macroscopic and the second one is the microscopic approach. Here is a table showing the basic differences between these two approaches. The first one, microscopic approach, considers gross or overall behavior, not taking into account events occurring at the molecular level. And in the microscopic approach, the approach is considered that directly the structure of matter is also known as statistical thermodynamics. In simple words, in microscopic level, we do not consider the events undertaking at the molecular level, and in the microscopic approach, we do. The second point is in macroscopic approach, it requires simple mathematical formulae. And in microscopic approach, advanced statistical and mathematical methods are used to explain changes in the system. Third point, in macroscopic, values of properties of system are average values. Changes in them can be felt by our senses. Whereas in microscopic approach, properties like velocity, momentum, impulse, etc., these cannot be measured easily, and hence we cannot feel them to our senses. The last point, to describe the system, only few properties are needed. And in microscopic approach, large number of variables are needed to describe the system, as we consider all the molecular approaches in this system. Another concept in thermodynamics is a pure substance. Now, what is a pure substance? It is a substance which is defined which has a homogeneous and invariable chemical composition, even though there is a change in phase. By example, here we can understand it more easily. Here, a picture of mixture of ice and water are shown. Even though these two entities are in different phases, but their chemical composition is invariable. They are of the same chemical composition, and hence we can call it a pure substance. Another example is liquid water, that is a mixture of water and steam. I would now like to conclude this session. This session was prepared by Atharva Deshmukh, Nirbhay Kosare, and Yash Gaikwad. We are all from second year mechanical studying at the PCCUR Ravit College. Thank you.